Very good morning to all. I'm Dr.C.Senthilkumar, Associate Professor, Department of Mechanical Engineering. I'm happy to give another lecture series on heat and mass transfer subject. So the topic is duct design. We all know what is meant by duct. It's a passage to pass the fluid or heat through the to the atmosphere or atmosphere to the system. System is where we are focusing the thermodynamic analysis. So introduction to the duct thermal analysis. So the purpose is to transport condition of air from a source to a destination with minimal energy losses. We all seeing now the IT industries having series of table and cabin arrangement like this. So they could not provide individual room to the all the servants or IT professionals. So what they do, they make this duct arrangement. Through that, they supply the cold air and hot air according to the climate change, according to the requirement. So the source cold air which is coming through this passage, which passes through this passage, which is aligned with the ceiling of the construction of the building. So the ductwork design is critical component of heat transfer analysis in HVAC, heating, ventilating and air conditioning system. Its purpose is to transfer heat conditioned air from a source to a destination with the minimal energy loss. So analysis of goal to ensure the air arriving at the destination is in the target temperature. Coming to the next one, the design thinking for ductwork thermal dynamics, where we see the thermodynamic analysis in the concept of design thinking. So our SNS institution are deliberating everything, including the syllabus, with the design thinking approach. We are the first Indian institution to deal the concepts with design thinking approach. So in the empathize, basic conduction and insulation were made with a thermal bridge. So define in the define part, we are going for the how it is being carried out. That definition will be taken care. So and ideate part, what we do, we advance the fluid dynamics and heat transfer analysis will be made for the concept of thermal analysis. After ideate, we go for the prototype where we give advanced computational fluid dynamics concept with the simulation and prototype. So that will be tested by the basic convection with the duct and it will be revised or reconsidered for the next case of consideration. Coming to the introduction to ductwork thermal dynamics, ductwork design is a critical component of heat transfer analysis in HVAC, heating, ventilating, and air conditioning. Already we discussed what is the purpose, what is the goal. So coming to the next one, the basic conduction and insulation, thermal resistance or value plays vital role. So for that, we are making insulation based on the heat transfer analysis and heat transfer projects. So the material impact is a great value for analyzing the resistance. So the resistance is nothing but here how slow the temperature is transferred to the atmosphere apart from the pipe. So it has to be transferred only the required place. So other places it should not transfer the heat. That is our objective because the loss of energy makes more cost effectiveness. So the heat gain and heat loss has to be managed wherever the people need the openings or air duct opening for their place, for their ambience, it has to give the coldness. Other places the coldness should not leak from the pipe, for that the necessary insulation being made. Coming to the next concept here. So the basic convection with the duct, the convection occurs between the moving air and the internal surface of the duct. So the material has to be chosen in such a way. Here the concept of boundary layer and flow velocity plays vital role. We know the boundary layer, a thin layer of air near the duct wall that affects how quickly heat is transferred. It plays vital role over there. Coming to the flow velocity, faster air generally speeds less time in the duct, reducing the total amount of heat lost or gained during the transport. So this has to be taken care while designing the prototype or while supplying the cold air to the needy place during the summer climate to the people where they are working in a cabin arrangement. So coming to the next slide, intermediate surface area and duct shape. So we all know that duct shape is very important because so it designed based on the requirement of the area, requirement of the place, requirement of the coldness and climate, the tropical condition. So many parameters are there. Here I have shown two geometrical shapes. One is circular duct, another is rectangular duct. So the circular duct have the minimum surface area for a given cross-sectional area which minimizes heat transfer through the wall, whereas the rectangular duct often used for space having but have more surface area leading to high potential for heat loss or gain. So circular and rectangular minimal surface area is in the circular case. Rectangular case more surface area we are getting. So we are going for the next concept to elaborate. So here intermediate surface area on the duct, rectangular duct and circular duct have minimum surface area. Rectangular duct is often used for the space having the more surface area. So advanced fluid dynamics and heat transfer. So this analysis would have been done by the CFD, computational fluid dynamics. In advanced duct design, the relationship between air pressure and temperature, rough internal surface, friction loss. So the friction loss is rough internal surface create turbulence, which can create the convective heat transfer coefficient. Already I taught in the previous lecture series what is convection, what is convective heat transfer coefficient. That is nothing but H. H is nothing but heat transfer coefficient, watts per meter square Kelvin. The pressure drop also very important parameter. It depends upon the geometrical shape. If the shape is rectangular, the pressure drop is different. For the circular shape, the boundary layer as well friction and pressure drop is different. So for the friction loss consideration, rough internal surface create turbulence, which can increase the convective heat transfer coefficient. As well, pressure drop, significant pressure drop can lead into the temperature change with the fluid. Coming to the intermediate thermal bridging. So thermal bridge occurs where highly conductive material like metal hangers or insulated joints bypass insulation. So engineers look for these leaks in thermal dynamic to prevent localized condensation and energy loss. So for the impact, thermal bridges can lead to mold growth if the duct surface temperature drops below the dew point. So this concept, we are going for another hot attack and cold air getting inside. So radiation in hot attic, radiation heat from the roof can significantly heat up duct work. So differential analysis, designers must calculate the temperature difference between the air inside and the outside the system. So it has to be considered very carefully to supply the required air condition to the needed place. So again, friction losses and pressure losses. So friction losses, rough internal surface create turbulence, which can increase the conductive heat transfer coefficient. Pressure drop, significant pressure drop, can lead to slight temperature change with the fluid itself. So with that, I conclude my session on the duct design and heat transfer or heat supply to the particular place through HVAC system. So any clarification, you are required to give message or ask any queries to get clarified. Thank you.